We are starting with Jee Advanced 2023 paper 1 Q1. This is from functions. Let's move on to the options. So for the option A is there are infinitely many functions from S to T. So as there are no constraints on the functions, so each value of each member of the set S can be assigned to any of the members of set T. So the number of functions would be the cardinality of set S to the power of cardinality of set T. Sorry, cardinality of set T to the power of cardinality of set S. This is 4, but this is infinite. So there are infinitely many functions. So A option is correct. B, strictly increasing functions from S to T. So for a function to be strictly increasing, we'll need that f x1 should be greater than f x2 whenever x1 is greater than x2 and x1, s2 and s. But clearly we can take 5 distinct points from set S which are ordered, which have a relative order, and the values they can attain are amongst the 4 from the set T. So not all of them can be distinct. So we cannot have any strictly increasing function. For example, let's say f1 by 6, f2 by 6. So they should follow this order. But it's not possible because we only have 4 distinct values in the set T. And we have 5 distinct values here. So we cannot have any possible way to allot these 4 values from set T to these 5 in such a case that this inequality holds. In such a manner that this inequality holds. So B is wrong. Option C. So continuous functions from S to T. So let's name these intervals, subintervals as these. Sorry. So the argument here is that any continuous function on S when restricted to S1 or in fact any of the Si would be some constant, let's say Ti. To prove it, let's say that's not the case. So let's say S without loss of generality, we have S1 and there are 2 distinct values, say T1 and T2 at points A1 and A2 that this function attains. So that is f(a1) equals to T1 and f(a2) equals to T2 for some continuous function f. So by the definition of continuity, we'll need that the limit of the function as x tends to a1 from RHS and LHS should be T1. That is, but as there are only discrete values possible, so in its immediate neighborhood, we'll have that the function should be constant to T1. So the function is constantly T1, say in this interval. Now let's say a1 prime is the largest value. A1 prime is the largest value of a in a1 to a2 such that f a1 is T1. We need to have such a largest value f a1 prime is t1, because there is an ordering in this interval and it's upper bounded. It's upper bounded because f a1 prime has to be less than a2, because f a2 is t2. Then in the neighborhood of a1 prime, by the same argument, we'll have an open interval around a1 prime in which the function will be constant t2, constantly t1. But that will contradict the fact that a1 prime was in fact the largest value in a1 to a2, which attained the value t1. So in fact in this interval we'll have another value of another possible member of S which is greater than a1 prime, smaller than a2, and attains the value t1. So this gives us a contradiction. So that means that any continuous function should be constant in these subintervals. So now we have 3 different subintervals and 4 possible values to fill in each of them. So we have total number of phases 4 into 4 into 4, which is 64, which is less than 120. So C option is also correct. And every continuous function from S to T is differentiable. Yeah, because in each of these subintervals they are constant, and these subintervals are disjoint open intervals, so the functions are continuous and a constant function is differentiable. So the answer is A, C and D.